So solve the inequality. We're going to factor it first. We look for factors of 24. What did we say one of them was? We already kind of went through it. 4 was it? 2, 12,
yeah.
1, 24. Okay. We're going to run through 12. So we're going to take the function and not have it less than 0 at the moment. What we're going to do is we're going to call the function f at x, and we're going to say f at 4 and plug it in just to see if we get a 0 here. So 4 cubed is going to be 64. 4 squared is 16 times 9. 144. That's right.
9.
It can't be positive, is it? It's got to be negative 4. Because I'm just going to get a bunch of positive numbers here.
1296.
Yeah, let's do it as negative 4. This would be negative. That will be positive. This will be negative. 26 times 4 is going to be 4. Carry the 2. 8, 9, 104.
Negative.
Negative. Plus 24. You guys want to add those together?
I got 0, yeah. Negative 4 works.
Yeah, it's going to be 0? Okay. Okay, I might have done the math a little incorrectly there, but we've on the calculator verified. Okay, so the very first step we're going to have to do here is we got to turn this into factor. Now we're done with it. Okay, so let's do some long division here. If this is negative 4, we're looking at when x plus 4. Put it in. We're going to get x cubed plus 9x squared plus 26x plus 24. If we multiply by x squared, we're going to end up with x cubed plus 4x squared. We subtract the 2. That becomes 0. This becomes 5x squared. And we bring down the positive 26x. To get 5x squared, we're going to multiply by positive 5x. Positive 5x times this will give us 5x squared. 5x, that's 4. You see something?
Yeah. No. Yeah. I thought I had to equal 26, and I was like, wow, that's not.
No, on the other one it won't. Yeah, because it keeps coming down.
24.
So after we subtract, yeah, then we bring down our 24.
6.
Yeah, plus 6, and then 6 times 4 is 24. 6 times x is 6x. Both positive. Subtract. Boom. 0. Great. Because it is remainder 0, we know that that actually worked. So the equation now reads, I'll write it in black here, x plus 4. X squared plus 5x plus 6. X squared.
And then you do the same thing for that one.
Plus 6. Yeah,
So
so
you can factor out easy.
there's a whole bunch of ways to go through it, but this one is actually just going to be x plus 1, x plus 5. If we use sum a factor.
Can I answer 2 and 3 or no?
2 times 2 and 3. Oh yeah, sorry, I did the reverse. You're right. It is x plus 2 and x plus 3. I did multiples of the middle that added up to the outside, which is incorrect. Good. Okay, so you found it, and we still got to prove. It's usually much nicer when they give it to us in factor form. These values are less than. So you can either use a chart or we can use a number line. Let's take a look. I said don't use a number line, but when you make an interval chart, you are essentially making a number line. So we're going to try to show how the two of them are the same. So if we look at this, say this was set, even though it's not, let's say it was equal to 0.
Yeah.
Okay. If it was equal to 0, then our factors would be negative 4 would be one of them. Negative 2 would be another, and negative 3. So negative 4, negative 3, and
Negative 2.
Negative 2 would be about here. Okay. What they're going to ask you to do for your chart is you're going to actually take each of the factors. So when they say each of the factors, what they mean is each set of brackets. So we have 3 sets of brackets here, and we can kind of draw them as rows on the side here. So we have x plus 4 as one, x plus 2 is another, x plus 3 is another. Okay. And instead of making it a number line, what we do is we look for the values between these. So we're looking for something that is less than negative 4. So we're looking for something less than negative 4. We're looking for a value, and we'll make that one of the columns here. We're looking for something between negative 4 and negative 3. So you'd say negative 4. So less than negative 4. Yeah. And greater than negative 3. That's another column. Another column here is between negative 3 and 2. So less than negative 3, greater than negative 2. And I should use the line. And then we're looking for x greater than negative 2. Next. Now, The reason we didn't use the actual values, like -4, -3, -2, is because according to this, okay, these should make zeros, right? If I plug in -4 here into all these x's, this one's going to come out as a 0. 0 times anything is 0, but we're not looking for equals to.
Yeah.
We're looking for just less than. If it gave us an equal to also, then the actual values that create zeros would be important. But because this is less than, or if it was a question that was just greater than, we don't actually have to use these specific points. They're essentially the x-intercepts of the function. Okay. So now that we have that, you can just find any value.
You guys kind of put 0.
Yeah, you can. You can just put 0. Really, all you need to do with these charts is look for positives and negatives. Okay. So we'll play with arbitrary numbers. Usually it's easier to use round numbers. So for instance, -4, let's use -10 as the value, okay? Or -5. Those are usually really easy to work with. -10 plus 4 is going to give us a negative, okay? So that's what's important. -10 plus 2 is going to give us a negative. -10 plus 3 is going to give us a negative. These negatives are important. We're going to call the function.
So you add it or multiply?
We multiply it. And the reason we multiply is because these brackets are multiplied by each other. Okay.
Well, I mean, like the number that we choose in between. So, like, in that we chose -10.
I should have been more clear. When we say a number less than 4, we're saying for x. So,
yeah.
-10 plus 4, -10 plus 2, -10 plus 3, they all become negative values.
Okay.
And we multiply negative times a negative is a positive, times another negative gives us a negative. So, because it gave us a negative, you're talking about when something's less than 0, when the function is less than 0. This is one of the instances. When the x is less than 4, the whole function is less than 0 because it is a negative value. Okay? If we run another number here, we can use 3. Oops. There you go. -3.5. So, -3.5 plus 4
Positive.
is going to be positive, exactly. -3.5
Negative.
plus 2 would be negative, and -3.5 plus 3,
Negative.
negative. Negative times a negative is a positive. Times a
so
positive is a positive. So this one is positive, so that actually doesn't meet a requirement. We're looking for only negative values here. 2.5, same idea. Or sorry, -2.5. Here it's going to be positive, negative, positive. When we multiply them out, we're going to end up with a negative. Meets the requirement. And the last one, -2. Let's just use 0, because that's usually a very simple one to work with. Yeah, so we get plus, plus, plus. Multiply those all out, and you get a plus. So that doesn't meet our requirement. So the intervals for when something is, when the function is negative, is anything less. So when x is less than -4, and when x is between -3. Now, have they given you a specific way they want you to write it out?
We
as
should
an
write
answer?
that way, or like they said, like soft brackets if it doesn't.
Okay.
If it doesn't equal it.
Yeah.
But they meant like in like the hard squared brackets
If it does. So your infinite will be a soft bracket because you can never reach. I don't know. Talk to your teacher about that one.
No, it's soft bracket.
Yeah. Okay.
Wouldn't that be a negative?
Yeah,
negative infinity to -4 is a way to write this.
And wouldn't it be a hard bracket for
No,
negative?
it doesn't equal.
No,
0.
because so that's when. Remember, we're talking about when something is equal to.
Oh. Okay.
If it was actually equal to, also we would use.
So it's like x
that kind of a bracket
x
for it.
less than or less
It just
than
saves
or
them having to
equal
remember those.
So
signs.
if it has like the little line there, then it would have the hard
Yes,
bracket.
exactly.
Okay.
Yeah. So we do soft bracket when it's just less than or equal
Yes.
or greater than. So then -3 and -2 soft bracket again.
Oh.
Yeah, and that just, like you said, just saves you from having to write the inequalities, like greater than and less than. You can just write those as the values.
If the sign was
Question said less than and equal to 0, right? Well, technically, we talked about already at -4 is a point where it's equal to 0, -3, and -2. Okay? So luckily, those are all already in these in this writing here. So we have a soft bracket for infinity. -4 it's equal to, so we do a hard bracket. And then in this one, because it's equal to -3 and -2, it's a hard bracket for both of them. Okay. If you were to write it as like a type of domain or range, you could say x is less than and equal to -4. And then you could say -3, x is less than and equal to x, and x is greater than and equal to -2.
So for no questions, do you actually like do those two? Like x.
Well, if they had asked, if they did this, what if they asked for greater than 0? Greater than 0 would have been the other two brackets, so too high. -4 and -3, because then we had a positive value. So let's use a different color here. Let's use black if they said greater than 0. So if they ask for greater than 0, we're looking for -4 less than and equal to x less than and equal to -3. And what was the other interval we said?
X is equal. I mean, X is
Greater
less
than
4,
2.
-4.
Though the other one would be greater than 2. So x is greater than -2. And if we write those like those brackets, you're looking at soft bracket -4, soft bracket -3. And this one would be soft bracket -2 to positive infinity. And then the only other option here, let's get another color, turquoise, hopefully that shows up. If they say greater than and equal to 0, same concepts, except these would be hard brackets here. Hard bracket -2.
Why would that be?
And soft bracket infinity. Because if it was greater than and equal to, it's touching -4, it's touching -3, and at -2, that's part of it.
It never touches infinity.
Yeah, infinity goes forever, so I believe that's the concept with the soft bracket on the infinity. I think it's a little more complicated than that. I don't remember the theory for it off the top of my head, but
Because it lags kind of like as you're doing it here, will it lag in on the video?
a little bit.